Hello everyone, welcome back to my channel. I am your science teacher, Sir Roy Kapul, and for this week, we will be talking about geothermal energy. The most essential learning competency that will be covered for our lesson is to illustrate how energy from volcanoes may be tapped for human use. So as we all know, this is the continuation of our previous lesson. Let us first have a short review of the past lesson. Last time we talked about the advantages of volcanic activity. Also, we discussed the disadvantages of volcanic activity. Now, let's go back. What are the different advantages of volcanic activity? These are fertile soil, tourism, geothermal energy, creation of new land, and of course, for building materials. On the other hand, for the disadvantages, these are lahars, snowy ardent, loss of life, damage to property, and effect on the environment. So there are pros and cons with regards to volcanic eruption. For this week, we are going to focus our discussion with what is geothermal energy. So we're going to talk about how to harness power from below the ground. So the word geothermal energy comes from the two words geo and thermal. Geo meaning earth and thermal meaning heat. In other words, we can say that geothermal energy is the heat within the earth. Now, if you are wondering, based on the illustration, we have what we call as geothermal reservoir. These are pools of water heated by magma deep below the surface. Water or steam can escape from cracks in the earth in the form of geysers, for sometimes as magma from a volcano. The ability to harness the steam is what powers a geothermal power plant. Now, people can capture geothermal energy through two ways. The first one is geothermal power plants, which uses heat from deep inside the earth to generate steam to make electricity, just like what is shown in the illustration. On the other hand, the second option is geothermal heat pumps, which tap heat in close to the Earth's surface to heat water or provide heat for the buildings. At a geothermal power plant, wells are drilled 1 or 2 miles deep into the earth to pump steam or hot water to the surface. If we're going to convert 1 or 2 miles deep, it is equivalent to approximately 3.2 kilometers. You are most likely to find one of these power plants in an area that has a lot of hot spring, geysers, or volcanic activity, since this will be the source of heat that will be converted to electricity, because these are places where the earth is particularly hot just below the surface. How does a geothermal power plant works? If we're going to look at the illustration, the first step is that hot water is pumped from deep underground through a well under high pressure. So that high pressure will causes the hot water to rise. The second one is when the water reaches the surface, the pressure is dropped, which causes the water to turn into steam. So the hot water is now converted into steam. The third step is that the spins a turbine, which is connected to a generator that produces the electricity. So it is the steam that makes the turbine move. Then it will convert the mechanical energy to electricity through the help of generator. Fourth step, the steam cools off in a cooling tower and condenses back to the water. And the fifth step, the cold water is pumped back into the earth to begin the process again. And then the cycle continues once again. Now, we have different types or examples of geothermal power plant in the Philippines. In our local area, we have the Macban Geothermal Power Complex. It is located in the border between Laguna and Batangas provinces. It is the fourth biggest geothermal power facility in the world, with an output capacity of 458 megawatts. In addition, in the Philippines, geothermal power plants are used to generate electricity. For example, we have geothermal power plant in Tiwi Albay, Kidapawan, North Cotabato, Calauan, Laguna, Tungonan, Leyte, and Bacon, Sorsogon. Now let us talk about the different types of geothermal power plant. I want you to look at this illustration. As you can see, it is what we call as a dry steam power plant. Hot steam from underground is piped directly into the turbines which powers the generator. So meaning to say, the pipe that sips the hot steam from the ground is directly connected to the turbine. And then it is connected to the generator to convert the mechanical energy into electricity that will be supplied to the different houses. The second example or type is the flash steam power plant. In this case, hot water from underground is pumped into a cooler temperature flash tank. The sudden change in temperature creates steam which powers the generator. In this case, the pipe that generates the steam is not directly connected with the turbine. It is first connected to a flash tank. Okay, that in order to convert the hot water into steam. And the third type is what we call as the binary cycle power plant. Hot water from underground is pumped through a heat exchanger which heats a second liquid that transforms into heat. So these are the types of geothermal power plant. Now, let's talk about geothermal heat pumps. Not all geothermal energy comes from the power plant. Geothermal heat pumps can do all sorts of things, like from heating and cooling homes to warming swimming pools. This system transfers heat by pumping water or a refrigerant. The key here is the term refrigerant. It is a special type of fluid through pipes just below the Earth's surface, where the temperature is a constant 50 to 60 degree Fahrenheit. So as you can see in this illustration, geothermal heat pumps works even during winter or summer. During the winter, the water or the refrigerant absorb warmth from the earth and the pump brings this heat to the building above. So since the temperature during winter falls down, so a particular building needs a heater. And geothermal heat pumps plays a significant role in order to heat the building. The second one is during summer. In the summer, some heat pumps can run in reverse and help cool buildings. So during summer, the function of geothermal heat pumps is the opposite of its function during winter. It provides a cooling sensation for the building during summer. Now, how does a geothermal heat pump works? The first step is the water or the refrigerant move through a loop of pipes, just like number 1 in the illustration. The second one, when the weather is cold, the water or the refrigerant heats up as it travels through the part of the loop that is buried in the ground. Once it gets back around above the ground, the warm water or refrigerant transfer heat into the building. Next step, the water or the refrigerant cools down after its heat is transferred. It is pumped back underground where it heats up once more and starting the process again. On a hot day, the system can run in reverse. Just like what I've been telling you a while ago, the water or refrigerant cools the building and then is pumped underground where extra heat is transferred to the ground around the pipes. Now, let us talk about the types of geothermal heat pump. The first one is the closed-loop system. Underground pipes circulate liquid that is heated or cooled by the earth. The liquid is then transferred via an exchanger to heat or cool the structure. So we have three classification under closed loop system, the horizontal, vertical, and pond or lake closed loop system. They just differ depending on the direction of the installation of pipes in the underground. The second type is the open loop system. Here, as you can see in the illustration, water is taken directly from a source and into the heat pump. It is then recycled back into the same source. These are the references that I made use for this particular lesson. Okay, class, thanks for watching.